Hey guys, welcome back. Today we are going to do some operations with vectors. So here are two vectors in component form. So I'm going to draw what those would look like in standard position. So you've got vector v is -5, +2. So vector v would look like that. And vector w is at 2, -4. So vector W looks like that in standard position. So we are asked to find vector U, which is 3 times vector W. So what we did in our previous lesson was graph these, or add them and multiply them and all those different operations graphically. So we would do this over 2 down 4, then we would go another over 2 down 4, and another over 2 down 4, and it would look about like that. So that's what it looked like graphically. But we're going to do it algebraically today. So 3 times vector W algebraically looks like this. So vector U is 3 times vector W. And 3 times 2 is 6. 3 times -4 is -12. So this is this vector, 3 times vector W. This is it graphically. It ends at 6, -12, and this is component form. So when you write a vector in component form, you've got an x component and a y component, your horizontal and vertical components. So that tells you that from its tail, it goes right 6 and down 12. Next is the opposite of vector v. Vector v is left 5 up 2. The opposite would be right 5 down 2. And algebraically, it's found by multiplying -1 times vector w. So that would be 5, -2. Vector v plus vector w. So graphically, we would have taken this yesterday and slid it down to here. And vector v is left 5 and up 2. So left 5 and up 2 would end right there. So vector v plus vector w would look like that. It would be at -3, -2. But if we do it algebraically, we would just be adding the two vectors. So the vector v is -5, 2, plus vector w, which is 2, -4. And when we combine those, we get -3, -2. So from the tail, it goes 3 to the left and down 2. Please note that you can only combine x components with other x components. And you can only combine y components with other y components. Then combining 3 times vector w with the opposite of vector v. So this is 3 times vector w graphically. The opposite of vector v goes right 5 and down 2. So from here, we would go right 5 more and down 2. So here's how we do that algebraically. We do 3 times vector w. And vector w is 2, -4, minus vector v, and vector v is -5, 2. So 3 times vector w is 6, -12, And from that, we are subtracting negative 5, 2. So we have 6 minus negative 5, which is 11. So from the tail, this vector goes right 11. And then negative 12 minus 2 is negative 14. So from the tail, it goes right 11 and down 14. And that right 11 down 14 is exactly what we would have gotten if we took this 3 times vector w and added the opposite of v. It's 5 to the right of this, which is at 11, and down another 2, which puts us at negative 14.